4 different electrical engineering concepts into Jurassic World, and attempting to use them to bring my dinosaurs from their hatchery to their nature preserve. I'm a college engineer, and I'm trying to figure out if I can have dinosaurs run through a park similar to how current runs through a circuit. Now, I put in quite a few custom rules into this park, and they all have a very specific purpose, because my goal of this game is not to prove that I can build a 5-star park, or that I can bring in a certain amount of income, or anything like that. Instead, I want to see if I can get dinosaurs to act like current in an electric circuit. So first, we're going to need the basics of a park to make this happen. Okay, so I had this idea the other day when I was trying to come up with a video idea, and currently I'm in an electrical DC circuits class for my computer engineering degree. Now, circuits is a really interesting topic of study, and I thought, how can I maybe integrate this into Jurassic World? So here's what we're gonna do. Now, this layout might look kind of similar to some of the other videos that you've watched from me, and that's because I'm going to be breeding a lot of dinosaurs in here to use as our little test subjects to see if they follow any laws of electric current. And I know we didn't really need any of these buildings as we're in creative mode, but I'm going to be having this park for a while, so I thought it was a good idea to put them all down. Anyways, let's get the inhabitants of our parks in here. Alright, here we go. We have quite a few dinosaurs. We might even have more than we did in the original Tesla valve video. But now we're going to have to go make their enclosure over there that we're going to try to funnel them towards. I have a hatchery and breeding facility where I raise mass amounts of dinosaurs to completion, and I want them to get to their paradise before they grow up the whole way. Along the way, I want the guests of the park to be able to see them, so I need there to be a couple of sections where they stop and congregate. Coincidentally, this is similar to how electrical circuits work. Over here we have the TRex Preserve. First, I needed to attempt to create a power supply and ground. Now, this is going to be acting as the ground. I knew what I needed to do in Jurassic World, but here's how it works in real life. Let me go ahead and move my keyboard real quick and my mouse. So in any circuit that you might have, you have the battery with the positive and the negative. Then there's oftentimes what's known as a ground. So our paddock is the current source. An independent current source is with a circle, or a dependent current source is with a diamond. The ground is going to be our enclosure, and you just kind of have to imagine that the circuit is completed between them. Alright, so the first thing we need to do is we need to make sure that these dinosaurs actually interact properly, and that they head over to their place. So we're going to see how we can incentivize them to do that. We're going to be coming back to this world over and over again throughout videos. We're going to add engineering concepts into this world one at a time. Let's just go ahead and demolish the gates and see if they'll go through naturally, and if so, see how long it'll take. Yeah, the majority aren't really going. If I wasn't able to get enough dinosaurs into the chute, they would not behave like I wanted them to put in some electrical engineering circuit concepts. I needed to get all the dinosaurs to move through the chute, but I didn't know how to do this. Let's go back and try this again. Alright, my other idea that I have is to do put a gate over here, and then to use the send summing technique of the ranger team to kind of send them all over. So let's hop in the ranger truck and see if we can do that. Also, unpopular opinion, the ranger teams in this sounds so much better. Alright. I'm hurting some T-Rexes here. There's a lot of T-Rexes in here. I think they're all trying to get in. But I think we may have unintentionally congested. Yeah, it looks a little bit congested. I had a way to funnel the dinosaurs, but now I needed to make sure that they could all go through the electrical wire that I wanted them to. I think we may need to open it up and make it wider. So let's go back, reload this, and try it again. I feel like this could be pretty good. Oh, I forgot to make a gate. These Jeeps sound so good in this game. Yep, head on over there. No, oh. Getting kicked over. Some people are called cowboys. I'm called a T-Rex boy. What are them wrangling these dinosaurs? Dino boy. I'm a dino boy engineer. Is this wide enough? This is actually kind of fire. How many dinos I'm hurting? One other thing that I should mention about voltage is it's a relative measurement. It's not absolute. So if you have voltage compared to a ground, it could be compared to like an earth ground, a reference ground, or another type of ground. You can also measure the voltage between 2 points on a circuit, and that's like a branch voltage. Alright, it appears as if our plan worked. All of the T-Rexes made it over. I had a proof of concept. I was able to prove that I could get dinosaurs to act like electric current in a wire. Now I just needed to add some electrical circuit components. Alright, as we're migrating our T-Rexes through from the left to the right, the first thing we're going to want to add is we're going to want a spot that they can kind of get stuck so that the guests can see them easier. So we're going to go ahead and add in some viewing platforms. And of course we're going to path everything up, but to do that, I think we're going to add a monorail track. Alright, now if we want the dinosaurs to be stopped right here so that the guests can see them, we're going to have to figure out a way to slow down the current. Since my engineering with the power supply in the ground went so well, I decided to take this moment and implement a resistor into my park. And this is what introduces the topic in DC currents known as a resistor. Now essentially how a resistor works, we're going to go ahead and you have your independent current source and say that's providing about 5 volts. The current's flowing this way. Now over here we have a resistor, 500 ohms. Voltage equals current times the resistance. So we have a voltage of 5, we have a resistance of 500 for the circuit, so the current for the circuit is going to be equal to 0.01 amps. This is what's known as Ohm's law. In the game, we're going to need something to slow down the dinosaurs right here, act as a resistance, and provide basically analogy to the resistor. But if you remember with our Jeep, we're going to need to leave this center part open, so we're probably just going to be as simple as narrowing the actual amount of room that the dinosaurs have. This should cause more to congregate right here, but let's see if that's the case. Hello, dinos. Go over there. It is time for you to become my dino currents. And go. All of you gotta go past the resistor. Now, does this look like it's slowing them down? Not really. The flow rate is just increasing on the inside, so they're acting a little bit more like a fluid than a current. Let's see if we can get this to change. I totally forgot to make the save with the guests, so we're just gonna have to redo that real quick. And my next idea for getting all of these dinosaurs to kind of slow up in this area is to use a bunch of rocks. Now I've learned from my previous experiences, a rock field greatly slows them up. Let's see if this slows down the dinosaurs at all and acts as a resistor. Did these Jeeps have V8s? Because it really sounds like they do. Come along, little doggies. Little dinosaur doggies. Alright, how are we doing? How are we looking? How are we looking this time? Alright, it does look like they're kind of slowing. They're not able to go at the same pace as before. A bunch of them, I don't know what these no's mean. Come on, boys, get through. Yeah, that definitely was harder. So I'm going to count that as a success. I was ready to integrate the third circuit component. After this, there's only one more component before my park was complete. The next circuit component I want to integrate into this flow from their hatchery to their eventual enclosure is I want to be able to put a switch in. When you have a circuit, it's what's known as a closed circuit, meaning there's continuity between the start and the ground. But if we don't have continuity, say here's our ground, we have what's known as a switch. And in real life, this can look like a light switch, a switch on your car, and if this switch is open, there's no current flowing to the resistor. If you close the switch, the current then flows. It's time to add a switch, and honestly, I think we're just going to use a gate. Now, if we think about this, this works perfectly because in Jurassic World, you can go ahead and open a gate and close the gate. In contrast with Jurassic World, when this gate is open, it's actually a closed circuit. And when this gate is closed, it's actually an open circuit. So let's go ahead and check this out. Bro, I swear, this is easily a V8. This has got to be a V8. Guys, if you know what engine this Jeep has, can you please tell me in the comments below? I'm a bit of an automotive nerd. I love cars, and I have to know what this is. All right, boys, head on over. All right, so we're going to start heading them over to that gate. Also, if anybody knows, can you tell me what the exclamation point with the no next to it is? Because I have no idea what that means, and I'm curious. I want to know. Boys, what's the issue? Can we not get through? Oh, I might have put the rocks too close together. Are these rocks too close together? I think they might be. I think that should be fine. Also, it looks like there's a side path they could take if they just had 2 of those deleted. We're gonna get you guys all to the staging ground, which by staging ground I mean right in front of this gate up here. Yeah, see? The gate was closed. Now when I use this and I open it, the dinosaurs can go through it now. So I think that this is a perfect example of a switch. Yeah, all of you go ahead and go through. Now I had one final component to put into the park, and this one was going to be the trickiest to do by far. Now there's one last circuit concept that I want to use, and that's the idea of a potentiometer. I forget what the symbol for a potentiometer is, so we're going to go ahead and look it up. Okay, it's like this. That's right. Let's go ahead and just move my mouse out of the way over here. So a potentiometer is kind of like a resistor. I have my independent voltage source. I have a little arrow, the resistor symbol, and then I come back over. This right here is a potentiometer. And it's like a resistor, but you can adjust the resistance manually. Say that I had a circuit, and the circuit was 5 volts, and I knew that I wanted the circuit to be 100 amps. V equals IR, 5 volts over 100 amps. So it's going to be 0.05 ohms. And that's what we would have to set the potentiometer to get this circuit to run at 100 amps. Now, I have an idea for how to do this in Jurassic World. And again, it involves gates. So let's say that I wanted another section for the guests to be able to view these dinosaurs. In this area, we need it to go by slowly. Usually, I would have the dinosaurs going through just one gate right there. But if I want higher flow rate, I'm going to add 3 on the outside. Let's see if we can see how much the dinosaur flow rate is affected with just one gate. All right, dinosaurs. It's time for your weekly migration. No, 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 no. Why are you kicking me? Stop kicking me. No, I don't want them to go through the left gate. Oh, this is turning out to be a disaster. I want to see how much a gate slows you guys down. Does this slow you down at all? I feel like that's not slowing them down nearly enough. All right, since these gates did not slow down the dinosaurs enough, I think I have a solution for it. I'm going to take a rock and I'm going to shove it right in front of the gate like this. So that the dinosaurs are forced to go through a narrower gap. I think they can make it through these gaps. I don't think that these gaps are crazy difficult. We're gonna put some smaller stones though, just to double check. Let's go ahead and test this out and see if our dino circuit works as we want it to. But before we see if this potentiometer works with the dinosaurs, alright, I have a challenge for you guys. Go ahead and make your own version of this park. Try to integrate some of these circuit designs, and then join my Discord and go ahead and post a picture of it in our media channel. Oh, the game is lagging. Holy cow. Alright, just go through that gate. Did I make it too complicated? Can you guys not get through? Oh, they definitely can't get through. Boom. I guess we got to take a couple of these away. Alright. Now, if we look, they should be having a tough time getting through, but what if we go ahead, open this gate? Look at that. Flow rate is increasing. Instead of having a bottleneck here, the dinosaurs can go around the side. So that's like we're changing the resistance. That means that this park is a success. If you have any more ideas of how I can put engineering concepts into Jurassic World, either drop them down below in the comments or join the Discord and put them there as well.